Welcome to my workshop. I built this wood lathe here, kind of like a metal lathe. It's got a cross feed, a saddle. It's got a power feed. Variable speed. I made it out. It's got a drill motor powering it, and I've got a light dimmer up here to control the speed. This video is going to go into how I constructed this lathe, and future videos will go into how to use it. It's also got a tracer attachment on the back. I've made a pulley maker attachment that clamps in the chuck. It's a very capable lathe. I'm really pleased with it. It's basically done. I'll probably add a few guards. I'll put a guard over my pulley here so I don't stick my finger in it. Maybe put a dust guard over the drill motor down here. But it's basically done. One other thing I'd like to do is hook up a vacuum attachment. It makes quite a mess. I cleaned up the lathe a little bit, but look at the floor. It's a lot of dust. But anyway, let's get on with the build video, and I think you'll find it interesting. Well, here's what we're starting out with. Some surplus steel, some square tubing, kind of rusty, but that won't hurt. These are used shaft, 1.5 inches. And I got this machine tubing here, part of a pump. It had threaded ends on it. I cut the threads off because I don't need them. Here's the tapered bearings I'm using. They were fairly cheap. I think it was $18 for the pair, maybe less, I can't remember. 1.5 inches on the inside, 2.6 about on the outside. I've cut one bearing fit in here, and we're going to cut the other bearing fit in this end right now. Okay, I've still got the lathe set up from cutting this bearing fit, so it should go pretty smoothly. This is the first time I've ever used this steady rest, and it worked really well. Okay, I've got the steady rest all set up. The outside of this tubing, somebody used a pipe wrench on it, and I filed it off pretty good, but it's going to be noisy. It won't hurt anything. But it's going to make a racket. You'll see. Check my depth of cut here. Taking about 20 thousandths at a time. Okay, we're almost there. I've got some hole gauges, but I don't have a 2 to 3 inch mic to measure that. It's 2 5/8 about. So I'm just going to have to be real careful and go a little bit at a time, keep testing this. I know where I was on the other end. I got the dials marked here, so we'll just keep cutting. And I think what we're doing now is just taking the spring cut from the boring bar. Yeah, I think I'm going to try to get that with sandpaper. I don't want to go too big. Well, I used a little emery cloth on it. I think it's just perfect now. Good press fit. There it is. That's the spindle bearings. Now I think I'm going to put a center in there so I can move this steady rest out of the way. Okay, I've got my steady rest set up. I got a grooving tool here. I'm going to cut a slot right here and put an 1¼ inch locking collar. This is an 1.5 inch shaft, but the locking collar groove is going to serve something for my bearing to set up against, plus a chuck set up against the other side, and it will allow a relief when I thread this area for the end of my threads. It'll probably be more clear later. I'm using the cutoff support plate that I made. I got another video on that. It really solidifies things. So let's see what it does. Okay, I'm calling that good. Next step will be cut my threads into that groove. And there'll still be enough meat right here the locking collar will hold. Okay, let's move on to the next step. Okay, here's the part I don't really like. Logan 200 has manual gears. Nothing wrong with manual gears except that they're a pain in the neck to change. I got to put a 32 gear here. Got to move this 72 tooth idler gear up here and put a 32 tooth screw gear on here. That'll make my cross feed move at the right rate. So I'm going to do that off camera. Well, there it is. Logan uses a lot of oddball wrench sizes. You know, there was a 19/32 wrench, same as 15 millimeter, but I had to make a special T-handle for different nuts on or bolts on here. Anyway, it's set up for 8 threads per inch now, hopefully. So let's see what it'll do. Okay, here it goes. Put a little oil on there. See what we can do. I haven't cut threads in a while. Okay, we're just barely touching there. Now we're cutting. Okay, definitely tight. That won't go on there. Well, there they are. I think my threading tool was a little bit dull, but I think it's going to work out. Chuck screws on there, and after I get that locking collar in there, it will seat and hopefully make it straight. It's fairly straight right now though. And I certainly think it'll be good enough for a wood lathe. Okay, I've finished the threads and I'm really pleased with them. I'm going to take this out and turn it around and turn this end down for a step pulley. Okay, I finished the sleeve here and pressed the bearing outer races in on both sides. Now I need to get an accurate measurement from the inner race on both ends. I don't have a caliper that big for dividers or whatever, so I came up with this. I know it's kind of makeshift, but it works. It works pretty good actually. Looks like a little over 8 1/8. So the lock collar I'm going to get is 1/2 inch thick. So I set the edge of the threads there on a 1/2 inch, and right about here will be where the outer race is on the bearing. I'm going to put 1/2 inch threads and a clamping locking collar on this end. So, and I want the bearing, I don't want the threads sitting on the inner bearing race, just a little bit. So I'm going to go in about right there, 1/8 inch in. I know that's kind of crude measuring, but it'll work. And then I'm going to thread from there on out about 1 inch, and then reduce the shaft the rest of the way to 5/8. Okay, I put the big chuck back on my lathe so that I wouldn't have to clamp on the threads. This chuck's a little deeper, and I was able to clamp on the actual shaft. Put my steady rest back on. It seems to work better with the steady rest. I got my center here. I'm going to turn down this section to 5/8 of an inch. It's quite a bit of turning, so let's make some chips. Well, there it is. That was a whole lot of turning there, but it's done. It's 5/8 of an inch. I'll have to cut a key in that. And I got to cut some threads right here for a threaded locking collar. Well, it took some doing. I was going to try to drill a hole and then use a boring bar and make these holes a little bigger. That didn't work too good. I got a problem with clearance on my mill here. Couldn't put a large drill in there and still have enough clearance to drill the hole. So I decided try a hole cutter. This one's made by Milwaukee. Seems to be a good one. Notice right in here, I've cut that hole already. So we're going to try cutting the second hole. Hopefully, I transferred it straight from side to side. I did my best to do it, but we'll see. Okay, here we go. Okay, I've finished cutting this groove for my locking collar. I took away from the threaded side a little bit. I got plenty of threads, and I may end up cutting some of them off. That's quite a bit longer than my metal lathe spindle, maybe an 1/8 inch or even a 1/4 inch longer. But yeah, we'll just see how that goes, see how it works with the chucks. But I think I got a good fit on this. Let's see what we got. I wanted a really tight fit, and I can just barely get that in there. It's exactly what I want. Yeah, it's all the way tight, I think. Now the real test coming up here is to screw the chuck on there and see if it runs true. Okay, here it goes. I'm not really sure what keeps the chuck centered this way? I guess it's just the bevel on the threads pulling when you tighten it. But the lock collar, or this surface here on your metal lathe, I'm sure helps the chuck stabilize this way. That went on there good. Real good. Here we go. Let's see how much wobble we got. Wow. I'm very pleased with that. Okay, I'll put my other chuck on here. It's a lot deeper. I got a lot deeper jaws, and I didn't want to clamp down on my threads. I had to take the locking collar off. Now I'm going to cut the threads for this. I've got a clamping collar. It will fit on the little thread on there. It's 20 threads per inch. And I'll be able to adjust the bearing tension with that clamping collar. So the next step is to cut 20 threads per inch to the right depth right here. Now I'm going to have to change gears there again for 20 threads per inch. So I'll see in a little bit. Okay, I've measured in about where I need to be. Need to be in about 490 thousandths. It'll thread onto about there. The threads will go very slightly, well actually this groove I'm going to cut will go slightly under the bearing. Needs to be about the depth of the threads, which is about 50 thousandths. So this is just a clearance for me to end my threads or thread into. So right there's touching. Need to go in about 50 thousandths. And I'm going to have a little bit of room to play with while I'm threading, so I'm going to go right next to that. I'd say that'll probably be wide enough. Okay, here it goes. A little more than I wanted to take, but we're doing good. Well, good working threads, but they're definitely not the finest looking threads I've ever cut. Well, let's put this together and see if I got it all right. Hopefully it goes better than the threading job I just did. So I think it'll be fine. Okay, I stuck it back in the lathe and sanded that little ledge there. There we go. I hope I get that right. Yeah, good deal. Of course, it's noisy right now because I don't have any grease in it, but that's pretty good. Of course, I don't know. I'll probably have to tighten that until I have a little bit of resistance and then back off a little bit. The next step will be to clean up this piece of steel here. And weld that tube into my, I guess you could call it my headstock. Okay, I'm going to weld this thing. I'm not a welder, so I'm going to do this off camera and wish me the best. Well, there it is. Still a little warm. Like I said, I'm not a welder, but I guarantee it'll hold. That's a lot of surface area. Well, I got a metal lathe chuck in there, and I chucked a 1.5-inch bar in there, and believe it or not, I gave it a spin, and there was very, very little run out at the top, no visible run out. Then I clamped some 7-inch blocks in there, and I visually aligned it this way. I'm lined up as near as I can tell perfect. So, and I know it won't be metal lathe perfect, but it'll be plenty good for a wood lathe. I'll strive for perfection and hope for the best. Well, it's time to weld it. Just to avoid any distortion, I'm going to weld one side a little bit, then go to the other side and weld. I really don't know, I'm not experienced enough to know how to avoid this distortion, but I'm going to do my best. Well, I got it all done. I'm getting better at this. I guess you got to learn somehow. Figured out what I was doing. It's a 110 meg I'm using, and I was trying to get too much penetration and staying in one spot too long. And after I started moving faster, it made a nice weld. Well, here's what I've done. I decided to just weld a piece of channel on the bottom. It'll have like a pedestal mount here. The bottom support's a little bit longer in the back, because the motor will hang off the back. Next step will be to cut a piece of steel to fit on the top. I got this surplus piece of steel here. And I'll cut that off flush, and then cut it to length here. I was thinking about wrapping it around the headstock. Just about that far. That way it'd give cross slide. I could notch out the cross slide where it gets up close to the chuck. But I'm not sure I'll do that or not. Okay, I've got my bed plate cut to length, and I've drilled a set of holes to bolt the bed plate to the beam. Also ground a relief right there for the weld, so it sits up against the headstock. I drilled these holes, they're 5/16. I'm going to countersink them. But I'm going to transfer the holes first. If you're trying to transfer a hole with a countersink, it's hard to hit center. So I'll transfer these holes, and and then I'll countersink all the holes. First I've got to center this up on there. Absolute center is not super important, but it's very important that it's square this way because my spindle is square to this beam. Now all we got to do is transfer the holes. If you haven't got a set of these punches, they're the best thing ever. They're cheap. Highly recommend that you buy some. Well, this is the easiest way I found to tap a bunch of holes. Use a pointed tap. Some people call them a gun tap. It pushes the chips ahead of the tap, and you can use a drill to tap with. You don't have to back up. Let's see if it fits. Well, I've been going through a bit of a learning curve on this mill. First off, I wasn't using any kind of lubrication. I was going to go with flood lubrication, and I don't have any drain setups in my table, and I'd have to buy a pump. And a friend of mine said I needed to get a mist lubricator. And I tried one, and it didn't work very good. I couldn't get the siphon to work, and I got this one here online somewhere, and it's got two controls. It's got both an air and a fluid valve. And with that, boy, it really works good. I've got an excellent finish on that. I redid that. The original that I had was usable, but it was a little rough. Well, anyway, I got the milling down pretty good. And then I went to drill these holes, and I forgot to lock down the head on this round column mill. And I got the hole spacing messed up. So I'm going to attempt to I'm going to attempt to salvage this mess up here. What I'm going to do is put in one extra hole and space them differently. Well, I'm doing it again. I'm trying to be a welder. I've already welded one. This is going to be a cap. I'm going to turn that off on the lathe. Getting ready to weld my second cap. Tack it in 4 places and then okay, I've got my large chuck on with the outside jaws. We're going to try turning this down. Looks a little dangerous, doesn't it? Well, I just realized something. My smaller chuck will still chuck that piece right there. This chuck is chattering a lot. And I think this one will do a lot better. See what it does. Ah, day and night. Well, there it is. Now I'll bore a hole in that and use a boring bar, and that'll be a dust cover for my bearings. I'll probably put a couple of screws right there to hold it on. It won't be a seal, but it'll keep wood dust out of the bearings. Not too bad. I think that'll make a nice dust cover. Okay, I'm going to make this hole first. And I'm going to make it the size of that lock collar. I think I can clear that screw, take the screw out, put the cap on, and then tighten the screw. Put the screw back in and tighten it. So I'm going to make it where it'll just slip over that. That's 2 inches, 360 thousandths. Drilled the pilot hole, and 1 inch is as big as I go. So I'm going to have to bore from 1 inch to 2.3. Okay, I just did the math on this, and from 1 inch I got to go 680 thousandths more. It'll be here a while. Well, there's one dust seal. It's pretty good. It won't go over the screw. I had to take the screw out and put it on there. Keeping that centered will be critical. I'll just put a couple of screws right there. Once it's tight, it won't go anywhere. Okay, I've drilled the dust covers for my bearings, and I've already mounted this one. I had to take out the set screws on the lock collar there and slide it on, and then transfer the holes and tap them. Fairly straightforward, but there's a clearance right here. I kind of had to tap it around before I tightened it to maintain that clearance. So I'm going to do this side now. Okay, I've just kind of eyeballed this. I'm looking for an even gap around the lock collar and the Looks good. Now I'll just transfer the holes. Looks good. Well, I kind of messed up the holes on the first slide that I milled, so I'm milling another one, and I think that happened for a reason, because I've decided to extend them about 3 inches. Here we go. All the holes are drilled. I've still got to drill clearance holes through this piece right here and then tap this piece. Okay, I'm in the process of tapping these holes. I just got finished with that one. That's the last one on this side, and then I got to turn it around and do the same thing. I've just used the center to find the hole and then measured 1.5 inches between them. So. Okay, excuse the mess I got going here. Too many things going. As always, get too many irons in the fire. Okay. I took a file to the tops of these holes just to make sure there wasn't any burrs on them. Same with the bottom. Same with that right there. So one punch. One punch. One punch. Okay, I've got all the screws in, and you'll notice here, make sure that you can see that. That's my cross slide. This has movement. So I can make it tight this way, and I'll have to put shims underneath here. If I tighten these, this won't move. And that's what I wanted. It's pretty close. It'll probably take a 1 or 2 thousandths shim. It's going to be a pain in the neck, but once you get it right, oh, look at there. Maybe a 1,000th shim. Maybe just sand right there. Wouldn't that be something? How about this side tightens up? Yep. I have to have more of a shim on that side. But you got the idea, and I'll have to shorten my bolts or get some 1 5/8 bolts. Yeah, 1 3/4 would be hanging over just a little bit. But I think that's going to work out good. Okay, here's my next step. I need to bolt this right here, drill holes and bolt that. And this will bolt on the back side. Like that. And there'll be some nylon tip set screws that go up from the bottom to adjust my clearance. Of course, I got to make one for the front and the back. Okay, here's a side view of the saddle with the front and the back, and that's for my threaded lead screw. There's a 3D of it. And here's all the holes I got to drill in the locations. And there's the brass tip set screw that I'm going to use to set the clearance on the bottom. It'll go right there. Well, let's start drilling. Okay, I'm on center this way, and I found the edge right there. That's my 0. Okay, this has to be threaded. So I've got to Switch to number 7 drill because it's 1/4 20. Well, there we go. Got one bar for the skirt done. I've already done the other one, so I got both of them done now. Well, I've started drilling the skirt for my saddle. I've drilled the 4 top holes, and now I'm drilling the holes that will match up with these. I'm just laying that there to verify where I'm at. I'm using the DRO to position it. I just like a double check. These will be 1/4 inch clearance holes. Okay, I'm starting the second skirt. I've located the edge here. I'm right on the edge, and I've already positioned it depth-wise. So my first hole needs to be 2.75 inches. It's 425. Okay, I'm getting ready to drill the holes in the end of my cross slide here, or saddle. And I had to put a small vise on my mill table to get the needed depth. I've got everything zeroed, centered, and found the edge right there, and I need to go 750 in. Okay, I'm fairly certain I don't have enough screws, but we're going to try putting this thing together. Okay, I opened up these holes just a little bit. I'm going to try screwing on these first. Bottom guide, if you want to call it that. Good enough though. Okay, there's the back side of it. That's where the set screws go, right there. Well, I'm going to have to take them back off because I was going to drill a little hole for a nylock set screw there so that I wouldn't lose my adjustment on these. So I'll have to take them back off. Okay, this one is the front because it's got the little tab for the threaded piece for the lead screw. So this one will go on the back side right here. Probably getting the idea now. It'll sit on the back of the lathe right there. So let's just put it on the lathe. And I plan on putting some kind of nylon on the bottom of that to help it slide. But the bottom will stop. The set screws will adjust the play out of it. I'm going to assemble the front side off camera, and well, a good way to drill a hole in the end of a long piece of square stock is put it in a 4-jaw. I've already centered it and drilled one and loosened 2 of the jaws. Should be pretty close. I tighten it up. Oh, it looks like it. Well, it's going together pretty good. There's the, I don't know what you want to call it, guide, brass set screws and a nylon tip. It hook some of the edge there, and I can adjust the set screws. First, I'm going to put some of this stuff on there. It's Teflon tape. And I think it's probably going to work all right to make this thing slide real good. If not, I'll replace it with something else. I was thinking about pinning some of that to it. That's UHMW. It's pretty slick. So I'm going to try this Teflon tape. Yeah, it'll be all right. Oh, that's pretty easy. So, hook's on right there, and this side, it's on here. Now I suspect when I tighten this down that I won't be able to move it. And that's okay, because I'm going to have to put some shims in here. This piece of metal was made from this piece of metal, just a section of it. So they're exactly the same length from here to here. So in order to get that thing to slide, it'll more than likely have to be shimmed. Yeah, pretty tight. Yeah, just put a piece of cardstock in there or something like that. I believe that'll be all right. More shims. It's going to take me a while to get it right. I'll put some shims under here and under here. That'll be my slide right there. Of course, I've got to put a lead screw to adjust this, and an adjustment on this. Well, I think I got some tweaking to do, but I got it fairly smooth here. It's got a little tight spot toward the end, like right here. I think this blade is warped. See, it's wearing the paint off right here and here. Anyway, it's probably good enough. The adjustment will have a lot of leverage to move that in and out. And this, doing pretty good. Now it's going to be moved from the bottom here. I don't think that'll be a problem. It's got some slop right here in order to get it to move better down here. I think it's going to do good. Okay, this is part of my cross slide screw. And I built this thing here. I got less than an ideal situation here. I probably should have designed it a little different, but this will work. What I got here is like a coupler. This goes through that piece, and this will screw onto here. And I'll pin that and then pin my 3/8 threaded rod into here. And this screws onto the bottom of my cross slide. And the part that I don't like is the amount of thrust surface right here, because this will be moving the cross slide in. That's going to be a wear point that I don't like, but I don't have much alternative. I should have left I should have designed it so that there was more clearance here, but that's all the clearance I got, so that's what I got to deal with. It'll be more clear when I when I get it mounted. Okay, we're looking at the bottom side here, the bottom of my cross slide. That will be where my crank is for my cross slide adjustment. I ran out of socket head screws, so I had to use some 7/16 bolts. Either one's fine. I like these socket head screws though. Yeah, I used 3/8/16 threads, so one turn is 1/16 of an inch. Kind of handy for woodworking. There we go, that works pretty good. A little bit tight, but I expected that. That's my lead screw block. The lead screw will thread through that. I gotta thread those for mounting, and I'll mount it on the lathe and then start working on the lead screw. Put a brass block right there. It's threaded for the lead screw. I would have liked to have made that brass too. I just didn't have a piece of brass. The brass will wear better on the threads. It's kind of self-lubricating and kind of like a bushing. Anyway, now I got to build the lead screw. Well, I found this big aluminum block, and I'm boring a 3/4 inch. Actually, I'm reaming a 3/4 inch hole. I've already drilled a clearance hole, and this will be the block for my cross slide, the bearing block, that sleeve bearing. This is just some surplus steel I had, or aluminum rather. Already had mounting holes in it. It'll just be my crank and the lead screw connect right here. This is a spring-loaded tap guide. It's a way of keeping the threads straight, which is fairly important on this. Yeah, here's what I got. Got some 5/8 rod here, and I made a brass washer on that and made a steel ring and just drilled a hole through it. It's got a number 10 bolt going through it to hold the ring in place, and that's my thrust bearing. Then over here on this end, I've got it threaded for 3/8. And I'm screwing the rod into the lead screw. Okay, I'm all the way in now. Now I got a lock nut on it. Now there's nothing stopping the lead screw from traveling that way. See, instead of moving the carriage, it's backing it out. So on this other end, I just have it sitting on some wood blocks just to keep it level. But I'm going to make a bracket right there and put some nuts on there as an adjustment so that it can't travel that way. So that's my next step, is to build that bracket. And I think I'll probably just let the threads right inside that. Maybe not. I haven't really decided yet. It probably wouldn't. There's no stress on the lead screw there. I'm not sure what I'm going to do yet. But on this end, I made the shaft for the lead screw kind of long. And the reason I did that, I'll probably have the crank right here. The motor, zoom up there a little bit. I'll have like a stepped cone pulley here and another one back here, so the belts will be running, the motor will hang back here, so this will be all clear of the belts. But by having this long shaft here, and I don't know if I'll do this or not, but it allows me the option to put a large pulley on there and a small one here and have the cross slide motor driven. And driving with the cross feed. I don't know if I'll ever do that. I'll probably just use it manually, but at least it'll leave that option open by having that long shaft there. So my next step is to build the other end of this lead screw rod. Oh, and if I haven't mentioned it before now, all the threaded rod is 1/16 or 16 threads per inch. So one turn will always move at 1/16 of an inch. Now on the cross slide, interesting thing about the cross slide is that'll move this in 1/16 of an inch, but it'll change the diameter 1/8 inch of whatever I'm turning. It's the same way on my metal lathe. They're in thousandths, on the new metal lathes, when you move it one turn, it moves it a half a thousandths instead of a thousandths, but it's taking off a full thousandths on what you're turning. But this one will be, I'll just have to think it in my head, you know. One turn, it takes off 1/8 of an inch because it moves the tool 1/16 inch. But we're getting there. It's taking shape. After I confirm that everything works right, I'll paint it and make it look nice. Okay, I got a thrust washer, or not a thrust washer, a flanged bushing right there, and I'm gonna cut that rod off about right there and put a couple of nuts on there, a nut and a lock nut, and that'll be the other end of my lead screw support. It'll also stop the lead screw from moving laterally. Okay, I got the lead screw cut off, and I need to come up with a little bit shorter, little narrower washer, because it's got to clear this right here. I want to eliminate any backlash. Well, seems to be pretty good. Oh, it's a wobbly lead screw. I'll probably lubricate that lead screw with dry lube, like a moly lube or a graphite. Look at that lead screw wobble. Sure be nice to get some straight threaded rod, wouldn't it? Well, I fired up the welder, took some old surplus steel and made a motor mount, and I should have this thing running in a few minutes. We'll see. Let's see what it's going to do. Yeah, look there. It's just an old drive belt I had on hand. It's not in very good shape, but it's looking good. I got this idea about a tool post, and you know, on a metal lathe you got this tool post. You can put about any kind of cutter you want in there, and I'm going to build a tool post for the wood lathe, kind of similar. I've milled a slot in there, and I just cut this to length, and I'm going to true it up with my metal lathe here. You'll just have to wait and see how this takes shape. May not work, but I think it's going to work good. Got to be careful here not to take off too much. It's not a good way to hold it in the chuck. I believe that did it. Yep. It's got a seam right there. I want to take that seam out of there. So I'm going to have to use a boring bar for that, and I'll probably go about that deep. I'm going to have to take it pretty slow because that's not very well supported. Looks pretty true though, doesn't it? I guess I went a little too fast. Okay, I think this will probably work better. I put my larger chuck on. It holds more of the tube. Had a little bit of trouble with that tube deflecting with my other chuck. Put the longer boring bar on too. Okay, I got this perfect fit here. It's actually a loose fit. It's got several thousandths clearance. And I'm going to make this about 425 thousandths from the top and put a mark here. I've still got the mill set up from when I milled this slot. So I need to measure the thickness of this. It's 140 thousandths. I need to put 140 thousandths shim on what I've already got in here. That'll make the depth and everything exactly the same, I think. We'll see. So I need to add 140 thousandths to this and clamp that in there. Okay, the tool is sticking out of my slot just about a 32nd there, I guess. So oh, it's plenty deep. I maybe should have made this slot deeper, but I think it'll be about right. We'll see. It's always the first time for everything. This is it. Okay, here we go. Here's my tool holder. That's the clamping mechanism. It'll have bolts. I'll put a cap on here and bolts in here that pull that up. And here's an example. Here's one tool I've used for woodworking. It'll hold it just like that. And index is from the top. I think I had it. I don't know how I use it. Probably like that. No, probably like that. Anyway, it indexes to the top of the cutting surface. Example right there. Indexes to the top. Here's something I use for cutting a groove, round groove. Put it in there, indexes to the top of the cutting surface, same thing. Here's a metal cutting carbide tip cutter, clamps in there to the top. It doesn't matter which size tool I use, it always clamps to the top of the cutting surface. So now I got to weld the top on this, drill a center hole to mount the post, and 2 screw holes right there lined up with that slot to pull this up. I've got the steel slug, if you want to call it that, for the inside of my tool post, and I've made this slot parallel to my vise, just eyeballing it. Right here I've got a center, that, just a recess from a drill there I did in the lathe, and a center drill here, and I'm going to use that center to measure from. I'm using my XY table on my drill press. Pretty darn handy. This won't be exact, but it'll be close. I could use an edge finder and go from this edge, but I want to drill 2 holes. Those will be my clamping bolts. Okay, there's center. Now, I want my bolts to pull up from the edge of that slot, but I can't have it too close to the center because that's going to be my mounting post for the that'll be the mounting bolt for my tool post. So I'm on center here, so I want to go from center the same amount in both directions. So I've got to get an Allen wrench and re-zero my my calibrated knob there. Okay, I've calibrated my knob to 0 so I can go exactly the same amount in both directions from center. How much I want to go, I don't know. There's 1/10 of an inch, 2/10, 3/10. 6/10 of an inch, a little over a ½ inch. I think that'll be far enough apart. Let's go for it. Then I want to go 6/10, 2, 3, and back on center, and then I go 1, 2, 3, 3/10. This is number 7 drill because they're going to be 1/4 20 bolts. I'll probably have to use, I'll probably start out with a tapered tap and then use a bottom tap to get to the bottom of those holes. Well, I drilled that hole, took a new bit and drilled real slow and was able to just catch the edge of that slot. Well, I think I went down about 1/8 of an inch of good threads there. I think that'll be adequate. Okay, I just drilled two holes 600 thousandths apart to match up with these holes, hopefully. And yeah, may have to get shorter screws. Nope, that worked. That worked. Perfect. And I screwed up again. It'll work fine now. I will now weld that right there. I screwed up because I almost got it too small. Well, I should have drilled the holes in further. Anyway, I'll weld that right there and then I'll trim it off on my lathe. I ground a little, or turned it in my lathe, a little recess right there to get better penetration of my weld, and then I took a piece of threaded rod in there, just the right thickness. The threads are kind of collapsing, but it'll keep everything tight. I'm using these screws to pull it up with. Which is essentially the same way I'm going to clamp my lathe tool. Well, there's a pretty bad weld there. Oh, hot too. But it'll work. I'll go cool that off and then trim it up in my lathe. Okay, I'm going to drill a center hole here. This will be eventually be the post that I mount the tool rest, the tool holder to the lathe with. The reason I did that is I want to support it with this wide center. Figured out the best tool to use on this. One I don't care about. It's just a cheap brazed carbide tool. Need to go a little more. Okay, I've assembled it. Got some pitting. That one was already there, but where my weld wasn't so good. But the lathe cleaned it up pretty good. The way you use it, put that tool in there like that and just tighten up these screws. There you go. The cutting edge is on center, at least if my tool post is on center. Cutting edge is always on center, or close to it. Depends on how you grind the tip. You know, that's just slightly lower than the top of the tool, but it'll be pretty close if I wanted to use that. And this is a wood lathe, so being dead on center is not going to be extremely critical. I like it. Well, I'm building a hand wheel here. I thought I had some, but from another project, but I guess not. Got these left over from another project. I'm going to drill those out to 1/4 inch. Yeah, took a pair of bolt cutters, cut that off and ground the threads, and I'll bottom out the threads in my hand wheel. I've made hand wheels like this before, it works pretty good. A little sloppy, it'll be alright. A little bit crude. I might improve on it later, but for now that's good enough. Well, this lathe is getting more complex by the moment. I'm going to build a tracer to work on the wood lathe, similar to what I had on the metal lathe. And I kind of overlooked one aspect. It's going to complicate the design a little bit, but it'll make it fun. What I did to use the tracer on the metal lathe is I removed this cover right here. It's just to keep the chips out of my lead screw there. And this screws onto that same place. I'm not going to demonstrate it, but I'll show you basically how it works. This sits back here. Like that. And I removed the cross slide screw that holds the nut underneath. So in other words, this is free to move now. And I position a tool post like that. And I hook this spring to my compound. And I haven't got both screws in it, so it's kind of deflecting. But with each pass, I can take a deeper cut by using this adjustment on my compound. Well, the wood lathe doesn't have a compound, so I've got to incorporate this type of adjustment on my wood lathe. So that presents another challenge. But I got an idea. This is some surplus steel I had. My wife wonders why I grabbed this stuff. This is going to be a bracket to hold my tracer, or the tracer pattern rather. I'm going to tap these holes. It'll give me a variety of different positions for that tracer pattern. What I'll have here is 2 standoffs and this plate mounted up on top with countersink screws. This right here will have a bearing on the end of it that follows my template. Well, time to test my welding skills. Not too good, but maybe I can make them more. Well, with enough grinding we can make it look good. Well, I should work pretty good. Okay, I milled off the aluminum block that I had mounted on the cross slide just to make it square. I had it ground off previously. Now I'm going to drill a 3/8 hole there. Okay. Good. That'll be my adjustment. I'll have a knob right here and either a nylock nut or a clamping lock collar on this side so that the thread stays stationary. It'll pull this back and forth. Those shoulder bolts will be right in there. Next step is to drill those shoulder bolts. Excellent. Now, I could probably get a shorter shoulder bolt, and I may do that at some point, but I'm just going to shim that up with some washers so that's held flat against that surface. Now all I gotta do is secure a knob onto that. This will be my depth control for my tracer. Cut this out of an old shaft or something that's a keyway in there. I'm going to use this for my standoffs. So I got to finish the edges and tap holes in them. Okay, I'm going to have to go out and get some more screws. Need another countersink screw for the top, probably a little shorter. I was going to put set screws in the bottom of that and just screw it into these holes here, but I don't have any 3/8 set screws, so I'm going to put a bolt in from the bottom. And if everything lines up right, 2 countersunk screws here. I know that's too long. Okay, I got screws in there just temporarily. Let's check our alignment here. This is a pattern. It's something I made for my tracer on the metal lathe, but same applies to the wood lathe. That'll be clamped right there, wherever I need it, with a pair of vice grips, and this will follow it. Of course, the cross slide is going to be motorized, so yeah, I think that's going to work good. And there'll be a spring hooked on here holding it against the gang. Getting excited about it. I think it's going to work out good. Well, the lathe is coming along. I've got the follower mounted now. That's a depth adjustment of cut. But you can see it'll follow the pattern really good. Of course, this will be spring loaded. But I don't like cranking here. I need some kind of speed adjustment. I thought about at one time mounting a pulley from here to here so that the spindle drives the lateral feed. But that, I'd have to come up with a clutch to disengage and engage, and then a reverse is even more of a problem. So I started looking at little servo motors. Something about right here, and have a sprocket and chain. But that was running into a lot of money. So, got to thinking, what is variable speed and reversible? And I came up with a solution, hopefully. Here it is. A no-name drill. I got it for 12 bucks. It was on sale. Normal price is $17 though. That's not bad. Fairly powerful, variable speed, works in both directions. The only problem is mounting it and making it convenient to change speeds, and I don't want to reach down and pull the trigger, but I got an idea. First thing I need to do is dissect it and see how it's put together. I may cut the handle off and mount it on the lathe. I'm really not sure what I'm going to do yet. Okay, Let's see what we got here. Well, it's kind of a shame to destroy this drill, but see if we can't figure it out. Seems to be pretty well made, actually. Well, I'm going to turn the camera off, and when I get back with you, maybe I'll have it figured out. Okay, not making a lot of headway yet. Power comes into the trigger control, and this little switch popped off the top. That's the reversing switch, and it's got a let's get it under the camera here, a diagram on it, which is probably going to give us some clues. Okay, the way I'm reading this diagram, in one direction these two wires will be connected, in the other direction these two wires will be connected. But let's test my theory with the ohm meter. My assumption was correct. There's a forward or reverse, and that's the other forward or reverse. I don't know which is which, but switches directions on the drill. So this is just a reversing switch. And this appears to be, let's see what we got in there. I think it's half-wave rectifier speed controls, like a light dimmer. Let's try something. I'm already at the point of no return. So if I bypass the switch, successful. Now, if it'll reverse, I don't know. Oh, perfect. Good deal. Figured out how to make it work for my application. Good deal. Okay, this little switch here has 4 terminals. One there, there, and there. So in one direction, these 2 terminals are connected together on each side. In the other direction, that's with the lever this way. With the lever this way, like that, these 2 are connected together. So I'll just have to keep that in mind when I wire my reversing switch on the lathe. Okay. I got all the wires stuffed in out of the way, I hope. And I'm going to cut that off. Cut the handle off. I want to leave that screw right there. This one won't matter, but these 2 hold the cases drilled together. Well, it took a little doing. Didn't have all the stuff I really needed to do it right, but it's good for a test. Got a lot of stuff laying on the bench. It's a good way to get electrocuted. In the neutral position, nothing. one direction. Reverse. Well, I've chucked a piece of scrap aluminum, industrial surplus again, in the fore jaw. And I'm going to enlarge that hole, kind of off center, put a couple of bolts through it and cut it in half and use it for a clamp to hold that electric drill onto my lathe. Let's see how it works. See what I'm doing? It was an existing hole and I'm cutting out that right there. $460. Well, I hoped I could cut that out with my pocket knife, that thin edge on there. I touched the jaw. Oop, nope. A little hard on my knife. I suspect a rat tail file is the best way to get rid of that little edge. It's only aluminum, so it should be pretty easy. Well, what I planned on doing with this, and that ledge came out real easy, is drilling 2 holes there, cutting it in half, and using it like a rod clamp around the front nose of the, just behind the chuck. The drill is made to have a handle on the side of the chuck, on the side of the drill body. I was just going to utilize that. But I needed an adjustment this way. I got it. I'll bolt it to a piece of metal and slot the piece of metal so I can move it. That'll work. Well, that's my mounting mechanism for my drill. We'll see if it works. Hopefully I got the diameters right. So I think that's perfect. Perfect. Now I'll cut slotted holes in here and that'll be my chain drive adjustment. That'll be mounted right here. And I'll put chuck a 5/16 or whatever size my sprocket is right there, shaft in there, and mount my sprocket on there, and mount another sprocket here. That'll be my chain adjuster. I've ordered sprockets, I don't have them yet. I got a 30 tooth and a 9 tooth. So it'll be a reduction of about 1 to 3. Well, there's my chain tensioner. Oh, I like having a mill. Cutting slots like that is pretty handy. I mounted the power switch, and this dimmer will mount on the top, and so will this momentary reversing switch, forward and back. The motor obviously has a switch to turn it off and on, but the dimmer and this switch always have power, but it's not until you momentarily turn it on that it changes directions, or is powered. I got the power to the motor coming out the back, and it goes into the, I drilled holes there, probably not UL certified, but it's good smooth holes there. And I wired them up through the tube here. I'm going to put a wood plate on the top to hold the switches. And if I want to change some things around, it'll make it easy to access it. But I got power now. See, that works good. Now, I don't electrocute myself. See, one direction, looks pretty good. What I'll do is these wires here, in hindsight I should have left the drill trigger on here. I could have kept all those connections inside the handle, but I'll push these wires in here, and I think what I'll do is make like a wire clamp and clamp them to the, I don't know if you can see that or not, just kind of clamp them to the square tubing there. Well, I got one of the two sprockets that I ordered, the larger one. That was supposed to be a 9 tooth, but I had a 16 tooth and I put it on there just to try it. I may end up getting a larger one here. I'd like the drill motor to run a little faster. It'll give me a little more control over the speed. But here's what I got. Works pretty good, but sometimes at low speed, if you stop and start, it kind of stalls. It'll be better when it's geared down. Okay, I haven't got a tailstock built yet, but this will show you what it does. You definitely need a tailstock. Well, thanks for joining me. That concludes part 1 of the lathe build video. This turned out to be a lot longer video than I thought. Part 2 will be the construction of the tailstock, It was quite an undertaking by itself, but it'll be a lot shorter video than this one. Thanks again for joining me.